day to everyone, judges and audiences. So myself Arhat Nag, and this is my project submission to DSH Hacks V1. So STEM education often suffers from a feedback latency problem. Students draw a diagram on paper but wait days for teachers to grade it or struggle with complex software that requires coding knowledge. We wanted to build a system where the feedback loop is instantaneous. Our inspiration was to create a creative scan, simulate, and learn loop that runs entirely in the browser, respecting student privacy while delivering enterprise-grade physics simulation. So this is the project. So let's start by doing start drawing. So this is a dashboard. Let's say I draw an inclined plane and then I click on analyze. You can see here it's inclined plane. Now let's launch. I can see here you can select the gravity, mass, ramp angle, friction, as well as bounciness. Now let's decrease the gravity, as well as let's increase the mass. Let's increase the ramp angle or decrease the ramp angle, as well as the friction too, as well as the bounciness. And then you can ask the AI that why is it accelerating. Here they give the reason as well as why forces are acting using the Newton's second law, F equals to ma. Now let's click on the pendulum. As you can see here, the pendulum works too. Here is the gravity. Let's increase the gravity as well as increase the mass. Let's increase the angle by 52 degrees and then string length, as well as let's increase the air resistance. You can see here your pendulum has length 200 centimeter and then 2 pi root over L by G. It's 2.84 seconds. Similarly, there's a projectile motion. You can see here the projectile motions launched at 52 degrees and everything. Similarly, there is a cohort roster. Here the student nivels will be there, as well as the lab assistants and teachers, how much they have masters and everything, as well as there will be nodes. And then there will be the mastery hub. There's a student performance hub. There will be how many lab hours, how much average mastery, as well as how many certificates they are given to students. There will be some engagement too. What we used is that we use the framework, the React 19, as well as Tailwind CSS for styling, and the Matter.js and for the physics engine. And then we use Canvas analysis for the computer vision. And then for deployment, we use Vercel.json. So you can watch a 5-second demo video. Click on launch. You can see achievement unlocked. There's assessment too, as well as there's calculator, whatever we are providing the values and everything. And there's a guide, draw the scenario, then set the angle, observe, as well as there will be a log, as well as there will be rank between the students and all. So this is my submission to the DSH Hacks V1 hackathon, and I thank you all.